Hey everyone, and welcome back to Gadget Lab Adventures. Today, we're diving into the world of physics with something super fun and super fast. We are going to build our very own balloon rocket racers. That's right, we're turning simple household items into high-speed machines. All you'll need is a balloon, some string, a straw, and a whole lot of curiosity. This isn't just about making something cool. We're going to see one of the most fundamental laws of physics in action, Newton's third law. It's the famous one that says for every action, there's an equal and opposite reaction. By the time we're done, you'll not only understand what that means, but you'll have your very own rocket to prove it. So, are you ready to race? Let's get started. First things first, let's gather our materials. It's a really simple list. You'll need some string, any kind will do, like yarn or fishing line. Next, grab a few plastic straws. Straight ones work best. And of course, the star of the show, balloons. It's a good idea to have a few different shapes and sizes so we can experiment later. You'll also need some tape and a pair of scissors. Finally, find two anchor points in your room. This could be two chairs, two doorknobs, or anything you can tie a string to, spaced a good distance apart. Make sure you have a clear path between them. Got everything? Awesome! The lab is officially open. Now for the construction of our rocket. It's incredibly easy. Take your string and stretch it between your two anchor points. Tie one end securely to one chair, then thread the other end through your straw. Before you tie the second end, pull the string tight so it's nice and straight. This is our racetrack. Now, take a balloon and blow it up, but don't tie it. Pinch the end to keep the air inside. This is our fuel tank. While you're still pinching the balloon, have a friend or use a bit of your own dexterity to tape the balloon to the straw that's on the string. Make sure the balloon is taped on straight and the opening is pointing towards the start of your racetrack. The balloon should be parallel to the string. And that's it, our first rocket is ready for launch. Alright, the moment of truth. Count down with me. 3 to ... 1. Release, whoosh, look at that go. Our balloon just zoomed down the string like a real rocket. So, what just happened? This is Newton's third law in its purest form. The action was the air rushing out of the back of the balloon. The reaction was the balloon being pushed forward along the string. The force of the escaping air created an equal and opposite force that propelled our rocket. It's the exact same principle that launches massive rockets into space, just on a much smaller and slightly squeakier scale. Pretty cool, right? You've just demonstrated a fundamental concept of rocket science in your own living room. But we're scientists here at Gadget Lab Adventures, and scientists don't just do something once. We experiment. Now we're going to become rocket engineers and try to optimize our design. What variables can we change to make our rocket faster? Let's start with the balloon size. I have a small round balloon here and a bigger, longer one. Which one do you think will be faster? My hypothesis is that the bigger balloon will be faster because it holds more air, meaning it has more fuel to push it forward with greater force and for a longer time. Let's set up to parallel racetracks to have a fair race. We'll release them at the exact same time. Ready, set, go. Wow, look at that. The larger balloon didn't just win, it left the smaller one in the dust. My hypothesis was correct. The larger balloon held more air, so when it was released, it expelled that air with more force, creating a stronger reaction and pushing the rocket forward much faster. The smaller balloon ran out of air much quicker and didn't build up as much speed. So lesson number 1 in our rocket design, more fuel, in this case, more air equals more power. This is a great example of how engineers think about trade-offs. A bigger fuel tank might be heavier, but in our case, the extra thrust more than made up for it. Let's try another experiment. What about the length of the string? Does the length of our racetrack affect the rocket's top speed? For this one, let's set up one short track, say about 5 feet, and one long track, maybe 15 or 20 feet. We'll use identical balloons, blown up to the same size, to keep it a fair test. We'll time each rocket from start to finish. My guess is that the rocket on the longer track will have more time to accelerate and will reach a higher top speed, even if it takes longer to finish the whole track. Let's launch the first rocket on the short track. Go! Okay, that was quick. Now for the long track and launch. Interesting results. The rocket on the longer track definitely looked like it was going faster by the end. While the short track race was over in a flash, the rocket on the long track had a longer period of acceleration. The air was pushing it for a longer duration, allowing it to build up more and more speed before it ran out of fuel. This shows that for a rocket to reach its maximum velocity, it needs enough time and distance to accelerate. It's just like a drag race. The cars don't hit their top speed right at the starting line. They build up to it over the length of the quarter-mile track. So our second design principle is that a longer burn time on a longer track can lead to higher speeds. Now for the grand finale, let's put everything we've learned together to build the ultimate balloon rocket racer. We know a larger balloon provides more thrust, and a long track allows for maximum acceleration. Let's go for the biggest balloon we have and the longest, clearest path we can find in the house. I am going to try and stretch my string all the way from the living room to the kitchen. For an extra boost, what if we add a second balloon? We can tape two balloons to the same straw, double the engines. Will this double the speed? Let's find out. I'm taping two big balloons side by side onto my straw. Okay, both are inflated. The track is clear. This is going to be epic. Houston, we are ready for launch. Initiating final countdown for the twin-engine super rocket. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Lift off. Unbelievable. That was by far the fastest run yet. The two balloons provided a massive amount of thrust, and the long track gave it plenty of room to fly. It shot across the room in a blur. So our final conclusion is clear, combining multiple engines for more power and giving it a long runway to accelerate results in the fastest possible balloon rocket. This is exactly what rocket scientists do. They add more booster rockets and carefully plan their trajectory to achieve the speeds needed to escape Earth's gravity. What an incredible day of science and engineering! We started with just a balloon and a straw, and we ended up exploring the powerful principles that govern motion and space travel. We saw Newton's third law in action, and we thought like engineers, experimenting with different designs to optimize our rocket's performance. The best part is that you can keep experimenting at home. Try different types of string or different shapes of straws. What happens if you add a paper cone to the front of your balloon? Does it make it more aerodynamic? The possibilities are endless. Science isn't just about reading textbooks. It's about asking questions and having fun finding the answers. I hope you had as much fun building and racing your balloon rockets as I did. This is a perfect project to do with friends or family, so you can set up multiple tracks and have your very own rocket race championship. Remember to share your results and your awesome rocket designs with us in the comments below. I'd love to see what you come up with. Thanks so much for joining me on another Gadget Lab adventure. If you enjoyed this video and want to see more fun science experiments, make sure to hit that like button and subscribe to the channel so you don't miss our next creation. Until next time, stay curious.